Okay, we're recording. So, like I said, we've already discussed how to describe categorical variables. We said that we do that using frequency distributions, right? Absolute frequencies and relative frequencies. Now we're going to talk about what we do with variables, uh, what happens when we want to evaluate relationships between variables. And that's usually the most interesting question when we do survey research. Right? For example, if we ask respondents about their attitudes about something, and we want to know if those attitudes are related to some other variable, right? That's when the interesting things, when we find patterns of or differences across different respondents, that things get interesting, right? For example, we may find that if we ask, for example, uh, respondents to tell us their attitudes about, I don't know, gay marriage, we'll see in a little bit, and we find out that different groups have different attitudes towards gay marriage, right? And we may even ask which variables are most likely to predict attitudes towards gay marriage, right? So this is when we start getting into more interesting research questions. We're not just describing what a population looks like, but we want to see how things are related in the population. Now, we said in the first class that relationships in the world of variables, those are assessed by, we know there is a relationship when values of when one variable moves or changes values, the other variable moves as well. Right? So let's say if we want to know if gender is related to attitudes towards gay marriage, as gender moves, let's say from male to female, do these attitudes change, right? And that's what we mean when we're talking about relationships. So now we are going to assess now, learn to look at how we look at variables and move one variable or some values of one and observe what happens with the values of the other. And we're going to do that for categorical variables. We have two categorical variables and we want to assess if they are related. Okay, so we're going to do that with contingency tables. Okay, so usually when we want to assess a relationship, let's say, we start with a hypothesis, right? Like, is this variable related to this other, right? That's, when we change this variable, what happens to the other variable, right? And we tend to think of variables as dependent and independent. For example, if we were to say, does or do attitudes towards gay marriage depend on gender, right? In this case, the dependent variable would be the attitudes, and the independent would be gender, right? And again, when two variables are related, we see that as the value of one variable changes, right? When the independent changes, what happens with the dependent? Right? When gender changes, what happens with the attitudes? If the variables are not related, and this is an important point, then if one changes, the other one does not change. If the attitudes for men are exactly the same as the attitudes for women, then gender has no impact on attitudes. There's no difference between men and women. So gender has no impact on attitudes, or attitudes do not depend on gender, right? So now, for example, if we want to see if there's a relationship, let's say respondents' age and body weight are related, right? And they are. Children, of course, tend to weigh less than adults, right? They have less body weight. So we should see that as age changes, right? We should see that body weight also changes. Like higher values of body weight have, or of age have higher values of body weight, right? If they were not related, then we would see that age, higher values of age have the same body weight as lower values of age, right? That's what would happen if we were not related. But of course, they are. Okay, so when we have categorical variables, the way to assess if changes in one variable versus change in the other variable is through contingency tables, right? And contingency tables are also called cross tabulations, right? Or crosstabs for short. And it is an effective way to assess relationships between categorical variables, right? Now, contingency tables, they are good for this because they present distributions of the dependent variable across different values of the independent variable, right? In a contingency table, the values of the independent variable, usually the cost, we won't hypothesize that, typically grow across the top of the table, right? While the values of the dependent variable go on the rows, on the side of the table. For example, let's keep with the example going. Let's say we want to know if attitudes towards gay marriage are affected or related to people's beliefs about the Bible, right? So we're thinking that attitudes towards gay marriage are related to beliefs about the Bible. So the attitudes depend on the beliefs about the Bible, right? So the independent variable is the beliefs and about the Bible, and the dependent is the attitudes about or towards gay marriage. So if we want to assess that relationship, we are going to create a contingency table. And again, this is coming from the data set that you're familiar with, which is the General Social Survey 2018. And you see here, let's start with this first column on the left. These are values of the dependent variable, right? These are attitudes towards gay marriage. And the way the question was asked in the General Social Survey was, do you strongly agree, neither agree nor disagree, or strongly disagree that homosexuals should have the right to marry? And respondents can say strongly agree, etc. Now, last week when we discussed frequency distributions, we would have created a frequency distribution for this variable, right? And we would have how respondents were distributed across these categories, right? How many said strongly agree, how many said agree, or what percentage said that, right? Now what we're doing is we are crossing two variables, right? We have that variable here, and then we have the other variable, the independent variable here across the columns. And you remember this variable because you did your homework about it. And it's respondents' beliefs about the Bible. And the way that question was asked was, please tell us which category best describes your beliefs about the Bible. Is it the actual Word of God? Is it inspired in the Word of God? Is it a book of fables or other? Right? So you have the dependent variable and the independent variable. And in the values inside of the table, right, you have many things. Let's start with this one, the grand total here on the last column. This one is everybody that answered to these attitudes towards gay marriage, right? This is like the absolute frequency for this variable, right? It tells you that out of everybody that answered these two questions, First of all, it's 1,949 that answered both questions. 304 of them said they strongly agree, right? And 686 say they strongly disagree, and so forth. Okay, now here on the last row, you get the frequency distribution for this variable, beliefs about the Bible, right? So you know that 655 out of all of them that answer those questions believe that it's the actual Word of God, and 916 believe that it's inspiring the Word of God, right? Okay, so these are the marginals, right, at the margins of the table. These represent the frequency distributions for the two variables. Now, in the table here, you have the number of respondents that answered both variables in that certain way, or both questions in that certain way. So for example here, 47 respondents said that the Bible is the actual Word of God, and also responded that they strongly agree with the right of homosexuals to marry. Okay, 47. 361 respondents answered that they believe the Bible is the actual Word of God, and they also responded that they strongly disagree with the right to marry. Okay, and so all of these are, like the number says, it's a cross, right? It's a tabulation of the cross here, right? So this here is 221 is respondents who responded that the Bible is it's inspired in the Word of God, and they also responded that they agree with the right to marriage. Okay? All right. So this is a cross tabulation, right? We have two variables. We have the frequency, absolute frequency distribution for both variables, right? And then we have the cross tab, which is the respondents that responded commonly on two categories of each variable. Now, right now it's very hard to see if these variables are related, right? Right now we just have counts here. But we can do several things with this table, right? Right now it's all absolute counts. But we can, okay, we talked about this before. These are the marginals, right? Now, like I said, it's very limited to have just the absolute frequencies, and you know that, right? So it's better when we use relative frequencies. Right? Now, when we were doing a frequency distribution, the relative frequencies were simple because they were just one variable. But now that we have a cross tab, we have many other options available to us, right? Because we can express the values as percent of all respondents that answer both questions, right? That's as a percent of the table total. We can express the frequencies as percent of the total in a row, or we can express the totals as percent of everybody in a certain column. Okay, how does this look? This is the relative frequencies as a percent of the total. Remember on the original table, we had that about 1,900 respondents answered to both questions. Right? Now, what we did here is we divided every number in the table by this total in the table and multiplied it by 100. So when we do that, when we have a relative frequency as a percent total, right? Then each cell shows the percentage of respondents that responded in the two categories, right, indicated by that cell. For example, 5% of all respondents, right, strongly agree with gay marriage and believe the Bible is the Word of God. Now, if you look at this, all this table here, which one is the most common combination of responses? Which one is the biggest percent in the table? Forget about the marginals, just look in the table. Which one is the highest number? It's this 1964, right? It's about 20%. What does that 20% represent? It says that 20% of all respondents, 20% of this 1949, right? 20% of them strongly agree with gay marriage and believe that the Bible is inspired in the Word of God. That's the most common combination of all respondents, right? Good. That's when you express the numbers in a table, a cross tabulation or a contingency table, as percent of the total. It allows you to see what the most common combination is. It's interesting, but it doesn't really help you to assess if there is a relationship between the two values. Anyway, that's the first option for us as a relative frequency, percent of the total. The second option is we could express the numbers as percent of row, right? In this case, we would know, we would get, right, the percentage of respondents that responded in the column categories for each of the row categories. For example, we would say, this is almost 13. So 13% of all respondents that strongly agree with gay marriage, right? 12% of respondents that strongly agree believe that the Bible is the actual Word of God. Right? That's what it's telling us. Here, if we were to assess this one, let's say this 63%, because this is the 100%, you can interpret it as, of those that strongly disagree with gay marriage, 63% of them believe that the Bible is the actual Word of God. Of those that strongly disagree with gay marriage, 30% believe the Bible is inspired by the Word of God. Of those that strongly disagree with gay marriage, 6% believe that the Bible is a book of fables. Right? And this is the relative frequency, right, for the variable Bible. Right? 30% believe it's the actual Word of God, 45% believe it's the inspired Word of God, 22% believe it's a book of fables. Okay, that is another option that we have. Express the numbers as a percent of rows. Now, we can also express the numbers as a percent of the column. And here, each cell shows the percentage of respondents that responded in the row categories, right? That responded these, for each of the categories of the column variable, right? So for example, here you know, out of those who believe the Bible is the actual Word of God, right? Out of those who believe the Bible is the actual Word of God, 17% strongly agree with gay marriage. Out of those that believe that the Bible is the actual Word of God, 29% strongly disagree with gay marriage. Out of those that believe the Bible is a book of fables, right, Out of those, 65% strongly agree with gay marriage, and about 4% strongly disagree with gay marriage. Okay? And this is the frequency distribution, the relative frequency distribution for the variable, for this variable. Okay, so we said that we could express the numbers as a percent of the total, right? Or let me go back in slides. This was our initial table. We could express this number as a percent of the total, right? In that case, we would get the percentage who believe the Bible is the actual word of God and strongly disagree. We could express it as a percent of the row total, right? 47 out of that. That would be the percentage of all those that strongly agree with gay marriage. What percent believe that the Bible is the actual word of God? Or we could express it as a percent of the total in the column. In that case, we would get, out of those who believe the Bible is the actual word of God, what percent strongly agreed? Okay. Now, when we want to assess relationships, we have to be careful about which one is the dependent and the independent variable, right? When the dependent variable is on the side, it's on the rows, and the independent is on the columns, we use the column percentages to assess relationships, right? So when the independent is on the columns and the dependent is on the rows, we are going to ask for percent of column to assess relationships. And this is because under this setup, the column percentages will let us know, or will represent, the relative frequencies of the categories of the dependent variable across different categories of the independent variable. And that's exactly what we want to do. We want to compare distributions, right, for each category of the dependent variable, right, across categories of the independent variable. Okay. When the column percentages are not identical, then there is a relationship. Right? In our example, the column percentages allow us to compare the different attitudes towards gay marriage across different beliefs in the Bible. Right? If these relative frequencies differ across different categories of beliefs, then we can say that these two variables are related in the sample. For example, we're back here to that table, and we're expressing the numbers as a percent of column, right? This column shows the relative frequency of attitudes for gay marriage. So it shows the distribution for this variable, but only for those who believe that the Bible is the actual word of God, right? If you were to cover this, all the other ones, right? This would be the frequency distribution of this variable of attitudes, but only for those with these beliefs about the Bible. This one here shows the frequency distribution for attitudes towards gay marriage, but only for those who believe the Bible is a book of fables. So if we compare these two, right, and they are different, then we would know there is a relationship, right? We can compare any two, right? If there was no relationship, the percentages across, right, rows would be exactly the same. In this case, they're very different, right? For those that believe that the Bible is the actual word of God, only 17% strongly agree with gay marriage. But for those that believe that the Bible is a book of fables, 65% of them strongly agree with gay marriage. That's a big difference. if we come here, out of those that believe that the Bible is the actual Word of God, 29% strongly disagree with gay marriage. But for those that believe that the Bible is a book of fables, only 4% strongly disagree. There is a big difference in the attitudes towards gay marriage between these two groups, right? Those that believe that the Bible is the actual Word of God tend to disagree more with gay marriage than those that believe that the Bible is a book of fables. So if we see that, right, if we see big differences in column percentages, then we say that, yeah, your attitudes towards gay marriage vary across beliefs about the Bible. And that means that they are related. These two variables are related. As you move your beliefs about the Bible, your attitudes change. So that is a relationship. It's a strong relationship. When these differences are big, it's a strong relationship. When these differences are all, when there are no differences first, when they're all identical, then there's no relationship at all. When there's small differences, the relationship is weak. Right? So when the variable is ordinal, right, it's better to compare the ones of the extremes, right? Like we said, strongly disagree and strongly agree. If we see differences across columns for those, for the extremes in the variable, then we have a strong relationship. Values in the middle tend to be a little more tricky, but on the extremes of an ordinal variable is easiest to see if there is a relationship. Now, how strong they are, like I said, we want to compare right at the extreme, like the strongly agree and the strongly disagree. For strongly agree, here we see a big difference. It's how many percentage points? There's a 48 percentage point difference between these two categories. Right? So there is a strong relationship. Anything above 10 percentage points is a considerable relationship. And so 48 is a very strong relationship. You can also use charts for this. But again, it's easier to see in tables, and the charts have to start from a table. So remember, when we are trying to assess relationships between two categorical variables, we want the dependent variable to be placed on the rows and the independent variable to be placed in the columns. If we have this setup, then we ask for column percentages and we compare these columns. If they are different, then we can say there is a relationship. If they are the same, then we can say there is no relationship. We can also see this on a chart. If you see, this is for respondents who said the this is a strongly agree, right, with gay marriage. And this is for respondents who said it's a book of fables. Out of those who responded that the Bible is a book of fables, 65% strongly agree with gay marriage. Now, if you go and look at those that believe that the Bible is the actual Word of God, only 16% say they strongly agree. Right? And 28% say they strongly disagree. You compare the 28 to the 3, it's a big difference. Anyway, I prefer tables. Tables are usually present an easier way to compare across columns, and the charts have to come from the tables anyway. So now we're going to turn into how to do this crosstabs or contingency tables using spreadsheets. And it's very simple. You already are way on your way to do it because you already know how to use this pivot table tool. Just remember to place the dependent variable on the rows and the independent in the columns, and ask for percent of column before you make comparison.